Okay, it's my honor to sit here to share our experience about the blockchain and the LLVM. And I'm very honored to be here. Okay. Sorry, so first let me introduce myself about me. I'm Zhong and come from Beijing. We are our Beijing team, and currently we have two offices. One office at Beijing, another office is at San Francisco. And currently we are working on startup project named Nebulas, a public blockchain project. And I was a co-founder and the CTO. And before that, I was the architecture of Alibaba blockchain department. And before that, I am the vice president. I am the senior engineering director of the Dolphin browser. Okay. So about the Nebulas, I give one slide to share a little thing about the Nebulas. Nebulas is a public blockchain project, and it's open sourced. And for Nebulas, it's aimed to provide search framework for the blockchains. So that's our thinking about blockchain. Okay. And at here, I will show our thinking about what's the blockchain and how the decentralized apps works, and then why we need LLVM and how and what we are done for the blockchain and the LLVM. So the first, I give a little slide to share more about the blockchain. So far, maybe you guys know that, maybe not. So I will give quick brief about blockchain. So far, blockchain is a very simple technology. So as this diagram shows that, so currently we want to transfer money from one to another, and in this case, we at least want try to send some money to Bob, and in the traditional method, they just send the money to the Bob, and Bob records their own ledger. But for the blockchain, it changes a little thing, makes all the users, all the network have all the ledgers, record all the information. So that means in that case, Bob, Alice sent to Bob. They didn't need to really send the money to Bob. They just create a record and tell the other guys, Alice sent the money to Bob. That means other guys will definitely know that Bob has more money and Alice will some. So that's the blockchain's. So that's the essential of the blockchain. To all this node, all the user maintain one public open ledger, record all the same information that prevent the trust issue, that will make all the data, all the information are consistent in the whole network. So that's blockchain. And from tech view, there are kind of different technologies. So in that case, the blockchain, as the name describes, there's a block record all the transaction information, and all the blocks are linked by chainability. So that means, for example, so there's a block, and then another block. The previous block, the hash of previous block was recorded on the next block. So from those functionality to make sure the data in any blockchain can't be updated, can't be out. If out, all the hash or the checksum are different. So all the chain, all the data were corrupt. So from that point, we use blockchain to record the data, to keep the data consistent all over the network. And besides that, there's a challenge to tell all the network how we can choose which block is the right at the current time. So there's two different ways. And one is about the Bitcoin represent the POW, proof of work. All the nodes are computer or hash to check for the SHA-3 hash to find out there's a nonce to meet the requirements. And if any one of them find this hash, so his block will be recorded on the chain, and the other guys, the other node will continue calculate the next block hash append of this. So that is a POW, the competitive. And another is about the collaborative. So that means just like the PBFT said, we select a team, maybe 12 or maybe 12 people, and all those guys create the block one by one. one by one. So that's two kind of different consistent algorithm. And so from that point, we can see that if your transaction is if your transaction are recorded on a block, and if there are more and more blocks append of them, so that means your data, your transaction are more safe and more secure than others. Why? Because there are more and more blocks append of this, so that will make all the previous block are more safer than others. So that's the blockchain technology. And a part of this, for the transaction itself, how do we identify Bob really can manipulate their own address, not Alice's? So that means we definitely will need to involve the crypto algorithm by using ECC algorithm or maybe RSA algorithm to protect their asset, to make sure that only the private key can change the asset. And the other guys use their public key to verify the transaction. So that's the blockchain. And from our point, we don't think blockchain is just a technology. We don't think blockchain is only used to be recorded as an asset, just like as Bitcoin does. So we think blockchain is a good technology to ensure the ownership of data. The ownership of data, for example, for Bitcoin. Yeah, if I got 1 Bitcoin, so there's just a number, a digital number. Everybody can see it and everybody can copy it. But by using the crypto algorithm, those data surely is my own. Only me can manipulate all the data, and the owner is me. That's ensured by the blockchain technology. So that's one part. So from that point, blockchain can be easily used for the IP asset. For example, some data, maybe some architect, some building inside the Minecraft game, maybe something like that. So that's one point. Another point is about the token. What's the token? The token means the Bitcoin. Yeah, the Bitcoin token, the Ethereum token, or maybe some ERC20 tokens, all is about the token. What's the token? Token is about the data value, the value of the data. Token reveals the value of the data. So it makes us provide our unified standard to rank all those values, all those data. For example, I have a CryptoKitty. I buy a cat from the CryptoKitty. So what's the value? I just name the price $1. And any other want to buy this, he may need to pay $2, maybe something like that. So that is the token does. Token reveals the value of data. So it makes the information, the data, the ownership, and the value in a closed loop to make all the ecosystem running together. So that's the blockchain. That's the blockchain we are thinking about. So how about this industry? So currently, frankly speaking, it's a crazy world right now. Or maybe more crazy, last year is more crazy than now. So far there's more than 1,500 cryptocurrency all around the blockchain industry. And then there are much more market to exchange the token from the fiat currency to the cryptocurrency. There's more than 10,000 all over the world. And the market cap is higher. Market cap right now is about $300 billion US. $300 billion US. And the 20 hours volume is about $16 billion. So it's quite a lot. And for the first blockchain project, or maybe we should see that the Bitcoin, the first e-cash system, which brings the blockchain technology, it has the most valuable, most large market cap. And after that is the Ethereum. So that's two famous projects. And I want to emphasize that the Bitcoin is the first project. It brings the e-cash system without centralized authority. All those nodes, all those that are management by P2P network, by some untrusted node, and trust by the mass. by the algorithm to control. And so that's the Bitcoin. And after Bitcoin was created, after the blockchain was found, the Ethereum, the Vitalik thinks we can never use technology to make the asset be programmable. That means we can create a rule for those assets at some situation, or maybe at some time, or for some target. Those exchange method or exchange algorithm can be changed. So that's why the Vitalik brings the smart contract, the idea, to the blockchains. That's why we see the Ethereum, the decentralized platform, decentralized application platform by introducing the smart contract. So that's the Ethereum. And so I want to share our experience about how the decentralized application works. So far, we all are engineers, so we know that how we write application is quite easy. It's quite easy. So there's a dApp, there's a front end written by some web application, maybe JavaScript, maybe HTML, or maybe by some mobile apps. Then there's a RPC interface to interact all the data with the blockchain, And all those blockchains are maintained by many nodes, So all those nodes are the same. The transactions, the data, the source code, the algorithm are the same. And all the data have replicate all over this network. So that means when our user just query his data, he uses RPC to query his data. The data on each node is the same. And the user can submit the transaction to any of this node. And this node will record the transaction to a block and broadcast to the network. So that's the decentralized application. So the major difference between the decentralized application and the traditional application is about the data. Data stored not only at one address, at one server, but also across the network. That's the difference. And besides that, another is about the economic. So blockchain is an open project, and all the node services are open. There's no some user login, some kind of facility to prevent DDoS, something like like the attack. So in this blockchains, we adopt the economic algorithm. So if user want to submit their transaction, to record the data, to do something on the blockchain, they need to pay for the gas. So that will make the attacker think about the ROI, about the cost and about the benefit. If the ROI is not good, it's lower than the profit is lower than the cost, the attacker won't do that. It's no use, it's meaningful. So that will make this public blockchain more stable and more safer by using the math, algorithm, and also economic principle. Yeah. So there are more features for the decentralized application. The one is all those source code, all those rules, all those algorithms of the smart contract decentralized application should be open sourced. Why? Because there are a lot of value, a lot of asset on the blockchain. How do I trust the service provider? We couldn't. Yeah, we couldn't. So the best way currently is to open source all those contract data, contract algorithm. We can review them, we can audit them. So that's one part. Another part is about the data. All the data must store at the blockchain. Can't be stored at other place, some centralized server. We can't do that. We can't trust them, just like the privacy issue Facebook just encountered. Yeah, so we should make the data open and public. And by the way, for the security, for the privacy, we can use crypto algorithm to protect them, to protect the privacy. For example, the ZKP, zero knowledge proof, something like that, to protect the privacy. But also we can prove those data are public, those transactions are really exist, and those data are on-chain. So that's the second. And the third and last one is about the cryptocurrency token. The application must use the cryptocurrency token. That means all the transaction should have, all the user should pay for the transaction. We should reward all those nodes, the owner of the node, to encourage them to provide those computing resource, those bandwidth resource, those storage resource. We should leverage by using this incentive principle. So that means the decentralized app must use a crypto token, but not only for the gas, but also for the value transition. So there are showcase. There are a lot of decentralized apps in the blockchains. And the two famous I want to highlight is about, one is Steam.io. Steam is a blockchain-based reward platform for publisher to modernize content and grow community. So that's one. And another is about the gaming, named CryptoKitties. CryptoKitties is about the collect and breed digital cats. So that's our two showcase. The two showcase, I think, perfect demonstrate the blockchain's capability. So we did some research, we do some work for the decentralized app, we have decentralized applications, but what about the pain? What do we encounter? So the first is about the security. Yeah, security, why? So blockchain is a financial system. Currently, there's a token, there's a value, there's an asset on that. So security is the most important thing. We need to find a way to guarantee the smart contract, the security of smart contract, but not only smart contract, but also the blockchain itself. So we need some security guarantee on that. And another is about the developer, about the toolchain. Yeah, for example, the Ethereum created their own language for the smart contract named Solidity. It's a subset of JavaScript. And for the developer, they need to learn a new language. And also, there's no much mature toolchains for Solidity so far. So for a developer, we think toolchain are not good and not enough. Toolchain need to be more user-friendly, developer-friendly. So that's second. And the third is about the execution environment. Execution environment is about the smart contract execution environment. So far, there's a lot of execution environment. For example, Solidity has its VM named Ethereum VM, and Corda has their own by using JVM. Yeah, and the Nebulas right now using Chrome's V8. Yeah, so that's a different VM. So we think if we can unify the execution environment to provide the same platform, for example, just like the ARM or like the PC computer, so we can build our application on top of them, unified. So there's no cost to migration to help all developers to build this blockchain's ecosystem. So we think execution environment is an important part. And the final thing is about the performance. Yeah, we all know that the performance always important. So we want to do that. So there's a pain. I can share more detail about those 4 pain. The first is about the security. Currently, there's nothing is done yet. There's a report. They said there are more than 3,000 Ethereum smart contracts has a security flaw. Yeah, why? Because blockchain is too young. It's still at a very early stage, and most developers in this industry didn't have much more experience on security. So that's the reason why we see there is a lot of smart contracts with flaws. For example, 2 years ago, there is a famous smart contract named the DAO, DAO, in the Ethereum. And at that time, the DAO smart contract raised about more than half of the Ethereum token to store on the smart contract. But sadly, there's a vulnerability issue inside. Hacker hacked them and stolen more than, how should I say, more than 10 million US dollar token from those contracts. So that's the hacker does. And there's no way to revoke those transactions, since all those transactions, all those assets are protected by the smart contract or by the private key. So in that case, the community of Ethereum are split. The one part thinks, yes, there's a security issue, we should fix it. So the Vitalik just do some hard fork to revoke all those transactions. So that's one part. Another part thinks, yeah, in our blockchain world, there's a statement named code is law. So if you write a buggy code, if your code is wrong, you have to face it. You have to accept the result. So they just keep those. They didn't reject the fork solution. They keep all those original results. So that's the Ethereum classic. So the community are split. So which one is good? Which thing is good? I have no idea. But I think as a human being, it's very hard to write bug-free code. So we definitely need to provide some tool to help them to write more secure code, not only for the smart contract, not only for the application, but also for the blockchain, for protect their asset, their data. So that's a problem. And the next is about the two-chain. Yeah, I just said. So Ethereum, there's solidity. Ethereum, there is solidity. Own create language. Ripple uses C++, and the US uses C++ and WebAssembly, and Fabric uses Go, and Java, and Corda uses Kotlin in Java. So developer need to learn a new programming language in order to develop smart contract, develop the decentralized apps on the blockchains. So it's a little bit hard for them. It's a little bit hard for them. So from that point, we think if we can provide more mature toolchain for those smart contract developer, it will boost all the community, make more and more developer come in to join to this community. So that's the second. And next is about the execution environment. Just as that, Solidity has their own virtual machine named Ethereum virtual machine. US uses WebAssembly. Yeah, but Corda uses JVM. Okay, so there's more virtual machine on that. For developer, they try to build their decentralized application on both Ethereum and the US. They have to learn two. They have to learn two languages, learn two different virtual machines, get to know more detail about that, to write bug-free, more secure code. It's quite a big effort. It's a quite a big effort. If we can provide a unified platform, unified execution environment, that will reduce all the risk, not only the production, not only for the production, but also for the security. And the performance, yeah, performance is always important, always important. And right now, Bitcoin, the average performance is about 5. Yeah, Ethereum is better, up to 10. Fabric is higher, but Fabric is not a public blockchain, so it's up to 1,000 TPS. So that is for the transaction. That is for the transaction, not for the smart contract execution. Smart contract execution is much more complex, and will need more computing resources. So we think we want to find another way to boost their performance, to make more and more business can build on top of blockchain. So in that case, performance is our key features if we can improve them. So besides all those pain, so how can we think? Why we think LLVM can do that? why we think can do that. One thing is about security. So I'm not very familiar with, I'm not the expert of LLVM, but we think, since there are IR bytecode in LLVM, all those C or C++ source code were translated to the IR bytecode, then used by the backend to generate the native execution code. So in that case, we can do some security check on the IR level. On the IR level, for example, we can check all those, we can check the instruction. We can disable some dangerous instruction, for example, system call, or maybe disable the I/O. And we can also limit the instruction, the memory use, the memory stage of this instruction limited to our given space, and also the instruction itself. So that will provide us a unified way to make the smart contract, make the code more secure. So that's, we think, the IR code can do that. Not only at the programming level, but also at the runtime level. And also, the security rule can be built inside this level. So we'll enforce the security for the smart contract. Yeah, so that's one part. And another part is about the current LLVM ecosystem. So it's a quite mature community. There are a lot of tool chains. There's a lot of front end. There's a high performance and a secure backend. And we can support more and more language, C or C++, Java, Go, C#, something like that. So that's another benefit about the LLVM. We have a mature community. We have a mature ecosystem to help users to write their smart contract by using their favorite language, C or C++, or maybe Golang, or maybe JavaScript, something like that. Yeah. And for the execution environment, currently all the blockchain nodes are running at PC. But if we want to leverage all those technology impaction for the mobile apps, for the mobile user, how can we easily deploy the blockchain node to a mobile device? It's hard. Currently, it's hard. We have to change all those tool chains. But luckily, for LLVM support different backend. Yeah, Mist. Yeah, some Mist, some X, some PCs, some platforms. So LLVM and its JIT can support all those platforms very easily. So that will make the execution environment and the platform supporting are more easier than other. Yeah, the last thing about the performance. Yeah, so I attended this is my first time to attend this conference. So I thought a lot of topic is about the performance and the security. So that is, you guys are working on. So I think performance in the LLVM community is not a big deal. Yeah, you guys are always do that. You guys are always do that. So we can rely on LLVM and its powerful toolchain and its powerful optimizer to help the blockchain to boost their performance. Yeah. So that's the reason we think we need to integrate LLVM with the blockchains. And we are working on that. Nebulas is working on that. So here is our architecture about the Nebulas. We just released our first version and released our mainnet at the last month. It's a fully functional blockchain system, just like Ethereum. And the difference is about the smart contract. Yeah, we integrate the Chrome V8 engine. It supports JavaScript, TypeScript language to write smart contract. And also it supports the WebAssembly. Yeah, and the performance is quite high. It's 2,000 TPS. But I don't think that's a big deal. Yeah, so that's what we are doing. So in this architecture diagram, we defined our virtual machine, Nebulas virtual machine, by integrating the V8 engine and LLVM we are working on. Yeah. So this is our architecture diagram we want to present, we want to implement it. Yeah. So there's two parts. One part is about the smart contract and our product code. All those code, all those smart contracts are written by C or C++ and then translated to IR bytecode, then deploy those bytecode. And then once the code be executed under the environment of the LLVM, and we need to provide some sandbox facility to limit the resource consumption, limit the API usage for them. So that's the Nebulas virtual machine does. That's the Nebulas virtual machine does. So we inspired by the mini SFI solution to provide our trust computing platform built on top of the LLVM. So we always opened our source code. So if you are interested, you can find the source code on our GitHub page. There's a partial of code and still under development. The reason is LLVM is quite complex. I have to admit that. Yeah. So currently, what about the challenge for this integration? The first and the majority challenge is about security. Yeah, for blockchain, security is the most important thing. Luckily, we have IR bytecode. We can check, we can make sure, we can provide our secure environment, secure sandbox to make sure there's less vulnerability issues. But we also need to define our well-functional sandbox on top of LLVM to limit the resource consumption, the instruction call. So that's one challenge for the security. We need to build a solid sandbox. We need to build a solid sandbox. That's one. And we also, the solid sandbox is for production, is for platform. But we also need to help user to write secure code. So that's why we need the secure toolchain to help those developers to write more secure smart contract, write more secure product code. So those things can be leveraged by some formal verification on top of our IR code. So there are some research, some professor are doing that. And others is about we just said about language, about the toolchains and the performance. So that is we are facing. Currently, we are trying to implement the mini SFI model on top of IR code, and we did some progress. But frankly speaking, it's not big, since we are not very familiar with the LLVM. But we want to let you guys know what we are thinking about blockchain, about LLVM. We want to encourage you guys to take more attention on blockchains, take more attention on LLVM for the security part, to make sure to make LLVM could be a secure environment, not only for the compiler, but also for the runtime, for the blockchains. That is what we are thinking about. So if you are interested, you can find our website at labs.io, and we do have GitHub address, and all the code are under that. And if you guys want to contact us, so there's a contact mail address, or maybe you can direct contact me, robin@labs.io. Okay, so here is my presentation. Thank you, guys.
Thank you. We have got a lot of time for questions. So, any questions?
Hello. Thanks for the talk. Earlier you mentioned gas. I was wondering how you do a resource restriction with the V8, because V8 doesn't know anything about these kind of blockchain constructs.
Yeah.
So that's my question.
Yeah, that's a good question. So far we didn't modify the V8 engine. So perfect solution is we rewrite the V8 engine, add some instruction code to calculate the instruction caller, executed instruction. So we didn't do that. It's too heavy for us right now. So we changed the thinking model. So we first pass the JavaScript code itself, and then we inject the tracing code inside of those JavaScript code. So that will make it more flexible to calculate, but without changing the underlying V8 engine. So I think that solution is the same with when we release the LLVM, the IR bytecode. We can do that at IR code level. We just translate all those IR code, add some tracing code inside before each instruction, so we can calculate the gas assumption, the gas consumption. Yeah. So that is what we are doing. Okay.
Any other questions? If not, then I will thank our speaker for his talk. Yeah.
Okay, thank you guys.